So anyway, yeah, this is our kind of 2030 for 2019. So we're really excited by this. We're inspired by it, and fortunately, we have clients who come to us asking for it. So as a 6-person firm, it's our focus. It's what we live and breathe. This is just a snapshot of some of the projects, most of our net zero and passive house projects in the last 8 years or so. And the bottom right corner is one that we're really excited about, which just is kind of coming on board, which is a retrofit of a Frank Lloyd Wright house here in Oak Park. So, all right. So the Carroll Center is a community center in Oak Park. It's a little kind of building that was originally built in the 1920s designed by John Van Bergen, who was a Frank Lloyd Wright employee, and then went out on his own and did Prairie School buildings. Then it was added on to in the 40s and the 70s. So there's kind of a mishmash of things that we were coming into. The rendering in the lower right shows kind of the big addition off on the left there, which is our project. The owner started by saying, listen, we need an addition here, and we want to, keep the budget down. So we designed a down and dirty addition, got the bid, and then they took it to the board, and the board said, yeah, but can't we do better? Because we had done a project for the Park District 4 years before that's a near net zero project that the community loves and the board is proud of. And so we got together with the Park District again and said, hey, the Illinois Clean Energy Community Foundation grant might be the ticket here. So this is a pretty amazing incentive program that we have in Illinois, because ComEd, the big utility, I think they sold a power plant, something they had like a $225 million amount of money that had to go back to the public. So they did it via this endowment that funds more efficient, energy efficient design. About 5 years ago or 4 years ago, they decided to take it from just funding lead projects to making it net zero. If you're going to get the big grant from them, you have to make a net zero building. So they give you like 60% of the money during construction, but the last 40% comes after you've proven a year of net zero energy. So the pressure's really on to deliver, and you have to choose a third-party certification, ILFI or FIAS, and so we did FIAS. So we got pre-certified, and really one of the big reasons for that is the kind of quality control that we know is going into checking the energy model, checking the construction, and knowing that the building is going to perform the way we think it's going to perform. Because if you don't have the quality control, you could be missing something big and not prove out your net zero. So anyway, we went in for ICCF grant, and it was approved for nearly a third of the construction cost, because what we were doing with the old building before was basically just repainting the inside. Now we're gutting it, and we're making it airtight, and we're insulating the heck out of it. And so it was a big change in scope, but that's what the grant is there for. I'm going to plug in my phone so I don't lose my power. So anyway, so that was a big deal. This is a quick orientation here. On the top is the existing zone of the plan, and on the bottom with the black fauché is the new section. So Oak Park has got more young families moving in. There's more kids. We need more after-school programming space. We need more daycare space. And the Park District wanted a big room where the entire staff could meet. They don't have any facility big enough to have their entire staff. So that's what this big addition was about. That's why the ceilings are as tall as they are, because they have kids in there running around throwing balls and stuff after school. And that's why there aren't a lot of windows down low. And then there's a movable partition down the middle so they can divide it up in the day for daycare. So the total ICFA for the project, the conditioned floor area per FIAS is 7,667 square feet. But you see the envelope to ICFA is about 2.7. It's kind of a sprawling building. So that's a little challenging in terms of energy modeling, as we know. So this is how we did it. The new construction is basically concrete block painted on the inside. Simple, cheap, durable. And then, you know, when you think about like the perfect wall from Building Science Corp, this is pretty close to that, isn't it? We've got an air control layer on the outside of that, which is the fluid applied, the orange stuff there. That's a Prosoco Cat 5 membrane, which Timothy will talk about in detail. He still has it, I think, in his clothes.
It's still on my coat.
Yeah. And then we've got our thermal control layer outside of that, which is 6 inches of mineral wool insulation. And then we have our water control membrane on the outside of that, which is the siding. Although the Cat 5 is acting as basically our drainage plane, we're flashing all the windows to that. And then we're wrapping up and over with our air tightness. We put a piece of Zip R, which is an insulated sheathing board, on top of the top course of block. And we basically extended our air tightness over the top of that and down, and our roof membrane is our airtight layer for the roof. And so that's fairly straightforward, I think. I mean, having done a number of passive projects, there were details to work out, like at the sill was kind of tricky with moisture and whatnot, but we did it. And then on the retrofit, it's kind of a different story. And I just want to kind of go into this saying, like what somebody else said earlier, we've done a fair amount of these, but I definitely don't feel like we have all the answers. I think that we have a lot of gumption, which I think is like equal parts bravery and dumbness or something. It's like a fearless willingness to go and do things and try them out. And we have made some mistakes, and I have presented to the Passive House conference about some of our mistakes and what we've learned. So hopefully we're not making too many mistakes here. We go to, you know, Building Science Corporation and all of you people in the community to learn and try to avoid it. But so on the retrofit side, we initially went into this trying to figure out if we could do it with cellulose, and realized pretty quickly that we had so many ins and outs that we decided we would retrofit this with spray foam. And so we sistered down the rafters, which are 2x4s, with 2x8s. And that allowed us to straighten out the ceiling and account for the deflection, leave the deflection alone in the rafters that are there, sister on. That gives us over 8 inches of closed cell. And then the wall assembly, we cross-ferred. So on the inside face of the 2x4s that existed, we put horizontal 2x4s at 24 on center. And so that gives us something to attach the drywall to, but it breaks the thermal, it creates a thermal break. So the studs aren't coming all the way through. We got an 1.5 inch cover over them. The foundation, we just spray foot on the inside. So you see that over on the right, I can't because I have people's faces there. But we basically put everything on the inside. So on top of the existing slab, we put a raft of insulation, put a new slab. So it's a shorter basement. On the inside of the foundation, we spray foamed it. So we basically were able to eliminate most of our thermal bridging that way, and kind of worked our way up the roof. Obviously, we have a little bit where the floor joists come into the foundation, but not too bad. I'm going to move quickly here. These are window details we can come back to. We used Alpine windows both at the new and the existing, different ones based on what we needed. For mechanical systems, we used a geothermal or ground source heat pump. It has a high COP, which is nice. And that lets us do all the heating and cooling with our ground source. Ventilation is with the Renew Air unit. That's you know, our energy recovery ventilation. And then domestic hot water is very limited. There's just a couple of bathrooms. They're not used a ton. So we just use a simple electric water heater for that. And then we need to get to zero energy, right? So we put a huge array on the roof, and our client, Chris, you're listening, I'm sure, he is just an absolute hero in the village and in the region. He's been outfitting Park District with solar for years. And so we're actually going over and above what this building needs, because here's the thing with that grant, we got to make sure we hit 100% or we don't get the last 40% of the money. But we're also, by overproducing a little bit, we're working out a arrangement with ComEd to see if we can kind of treat the overproduction as community solar, basically. So anyways, it's a 27 kilowatt rated array. It's a bunch of power, 79 panels. You'll see them here in a second. So here's Woofy Passive. I'm not going to delve into this too much. Pretty complicated utilization pattern. We had to get in there, all the kids at the different times and adults at different times, evenings and weekends. What we learned from our previous project with Park District is that, you know, as we all know, there's no such thing as a net zero building, just buildings that are used to be net zero. So you have to really be careful about your utilization, and you have to be conservative when you're using the building, or else you could throw that off. You'll notice the one red X on heating demand. This was one of the last projects that was allowed to have, or I think you need to have all green check marks now with 2018, but we were allowed to have one that didn't quite meet at the heating demand, and this sprawling building definitely made that a big challenge. So we got pre-certification on my wife's birthday in 2019. Nice birthday present. All right, now we're going to dash through some construction photos. I'm going to turn it over to Timothy to kind of take you through, because I should just say before we do that, the Park District, we went out for bid for this, and we got those kind of like, oh my God, bids. And they asked us to construction manage it. And we said, well, listen, we haven't done that before. We'd love to, because we've worked with you a lot and we have a great relationship. We kind of negotiated how that would work and what we would do and what we would not do. We're not taking builder's risk insurance, et cetera, but we're lining up the subs. And then, of course, what happened was Timothy became the instrument to this being a successful passive house project by looking out for all those details that so easily can get missed, particularly the air barrier. So anyway, Timothy's training is architecture, but he's one of those rare individuals that goes very smoothly into the field and into the office. So anyway, Timothy, take it away.
Thanks, Tom. Just on that note, I want to take a quick moment to shout out to Chris Lindgren. Every great project starts with a great owner, and Chris, it's been great to work with you in the Park District of Oak Park. Thank you for being an adversary for causes like this, where firms like TBDA can build great projects. So Tom did a great job breaking down kind of the nuts and bolts of the drawings of the project. We're going to dive into some of the construction photos. What you see here is insulation of the existing and new foundation. In the existing building that John Van Bergen designed, we put 6 inches of EPS on the existing slab, and then we used 2-inch foam around the edge, not only as a thermal break from the old foundation wall, but also as a screed for them to put the new concrete slab on there, just a little bit of an isolation joint, made it easier for them to do. In the middle, you can see a photo of insulation preventing a thermal bridge. That's an exterior uninsulated foundation retaining wall at the intersection of our building. So it becomes very critical when the concrete guys are pouring to have all that foam on site and make sure that it's all there, because if it's not there, the thermal break isn't happening. This is just a little bit, a few more photos of the foundation. One of the parts of the foundation that's important is you can see the peel and stick membrane on top of the foundation wall. That's the capillary break. A lot of you know that the capillary break is very important. There are different locations where you can put the cap break. In this particular project, we did it on the top of the wall. Another contractor did that portion of the work. I did not do that portion of the work, but essentially after that portion, the air barrier work came down to me and Chris Lindgren of the Park District. You can see the worker there is applying the damp proofing that worked as the essential preliminary adhesive to keep the exterior insulation on the wall. And then the other photos on the right, you can see there is actually a pier there that was not located properly. So we had to cut back to the control joints and make sure that the pier was located properly. I located it properly with the concrete contractor the morning of, and then when I came back, he fell back to an old set of drawings and whatever. There's things happen in construction. But the point is, we got past it. It got insulated properly. The stego wrap was continuous, and life goes on. Tom started to talk about this before, but I think this is probably of interest to some of you. When Tom first approached me about this project and being the construction manager, the thing that I was most scared about was the air barrier. I've worked for him for long enough to know that consistency in the air barrier is important, along with consistency in insulation. But on an existing building such as this, we're stuck with a bunch of conditions that we have to deal with. So originally, the air barrier strategy was to use an aerosolized product called AeroBarrier. And I met with the local individual on site a few times, and we talked through it. And he let me know that because the AeroBarrier is a proprietary product, it's very expensive based on the amount of product that you use to fill in the gaps. And so this building, with the shiplap sheathing that was present on the walls and on the roof, the amount of material that was expected to have to be paid for to fill all these gaps was going to be astronomical. So we had to do something that we don't like to do. I've learned working for TBDA, Tom never really likes to use closed cell spray foam as an air barrier. And in this case, we really didn't have much of a choice. And frankly, doing a building like this, part of this is education and seeing how things work. We moved forward. We talked through it. We looked at AHR values. We talked to some other consultants. We moved forward with the strategy that we weren't going to use AeroBarrier because it was going to be too much of a change order to the client. We were going to close cell spray foam the walls and the roof. And as Tom mentioned before, the walls and the roof were made more robust so that we knew that we were meeting our R value targets. But really, the fear in here was not being able to get it air sealed properly. So the plan.
Well, just to jump in there quickly, I think we had the AeroBarrier in our back pocket, but they said you better spray foam it first, because if we try to, we knew we were going to spray foam for insulation. They said you better spray foam it first because that'll reduce the amount of AeroBarrier you need by a huge proportion.
Absolutely.
And so we did that, and then we tested it, and we made our air barrier, we made our air tightness.
Yeah, originally the step one was just use all AeroBarrier, and that was overruled. And so next, the idea was to use it after we spray foam, just to fill in the other potential gaps and cracks that have formed. But we had the great readout from the first blower door test. Our third-party raters were like, yeah, we don't think you need it. And part of that process was using the Prosoco products of joint and seam filler and air dam in the existing building to really fill in and create a consistent air barrier wherever possible. I know I'm kind of going on about this, but the air barrier in the existing building is really important. One of the things that we really took pride in, and that isn't typically done, is that we, once the demo was complete, we vacuumed out all of the sill plates and made all of the existing framing extremely clean, not only to help the building properly deal with moisture moving forward, but to also any gigantic gaps or large gaps that were in the sill plates or in the sheathing or in the wall to roof connection were filled with backer rod and then used. Joint and seam filler was mostly used because it's the best product to bridge the large gaps. So at the end of the day,
we got some books here. Yeah.
Yeah. These are a few photos of kind of the frame connection of the old and new. It's a great concept, because one of the great things about this project is that not only are we preserving an old building that's worth preserving, but we're literally branching out and attaching it to a new structure. Mostly the idea of the new framed connection was it's a zip sheathing air barrier. Zip sheathing is great to work with. You can see a bunch of the tape there, but they also have a great liquid zip product, which came in very handy on this project. The other photos, you can see the kind of connection to the rough CMU box there. We're going to get into photos a little bit later of how we dealt with the air barrier there. And then you see kind of almost at the end there where they're putting the final cement board panels over the horizontal hat channels, over the Cascadia clips with the Z's on the exterior insulation. So you're starting to see the building start to take shape there. This is just a little bit of a breakdown of kind of some of the trials and tribulations of trying to make an existing building airtight. It is doable. It's a daily battle. It's something that you need to kind of have conversations with your subs about and make them aware of. I need to do this before you do that, because if you do that before I do this, I can't do this. So the zip tape, you can see On the left is almost part of a process. That tar paper that's there is part of the existing building that was laid over the existing shiplap sheathing. So later on, we went back and zip taped that in. In the upper right corner, you can see one of those moments that I was describing before. Those are plywood pieces that are put in every rafter bay. And then backer rod was put around the edge and joint and seam filler was put in there just to create some type of consistency in the air barrier. We knew that that was a gigantic spot of leakage, so we really focused on the top of the wall. And then the bottom right photo you can see is a little bit more of the air barrier kind of construction of the old canoe. You can see the brick wall there on the right, and then it's the zip sheathing that's all taped, and the roof is there, and you can see the parapet, and that's actually the main entry of the building there. This is Chris Lindgren. I know you're smiling right now. Another shout out to Chris. We did the Cat 5 air barrier on the CMU. I know a lot of you guys are really intelligent into their stuff. I will say Prosoco has a great team. They're amazing to work with in the field. Everything that they say on the website about them is true from my experience. They go above and beyond and out of their way. The problem on this particular project is that the CMU as a substrate for an air barrier is way too porous. It took more coats than we were told to get the wall coverage. This is what's known, that's me over there on the left, putting on the KISS coat. It's supposed to be the primer coat for the Cat 5. And we ended up going around the building several times. But at the end of the day, the lesson learned on Cat 5 is that the substrate is important for specification for you architects out there. If you are putting it on a substrate that's not, a sheathing product or something that comes from, zip or wherever it may be. So that basically took the whole month of December. And then you can see there in the photo in the middle, that is the continuation of the air barrier transferring up to the framed cap that Tom mentioned before. So essentially the CMU wall goes up. We put joint and seam filler at the connection between the CMU wall and the zip cap. And then that's the zip tape that's indicated there, essentially fastening airtight connection of the TPO to that framed buck that we're using at the top of the parapet. A couple of the other photos there are, you have the air barrier at the wall, but you also have the air barrier at your windows. So you can see the fast flash coming in there on the interior, and then you can see the air dam, which spans the gap from the window frame to the fast flash. So there is backer rod back there to span the half-inch gap, and then that's an air dam, which is also another great product from Prosoco. This is a slide to depict one of the more difficult parts of the project, which is doors. These are actually photos of the aluminum storefronts. You can see in the first two photos on the left, there's a piece of stego wrap there that's kind of loose, and that was taped with the stego tape. And then we used the Prosoco products just to get a good seal there at the capillary break and the stego wrap. The other two photos, sorry, the other two photos are great photos of the existing building, trying to get that air barrier as consistent and thorough as possible. One of these is showing the aluminum storefront, and essentially what we ended up doing here is putting a buck on the framed wall that then we were able to use a can of spray foam to create consistency to then apply the fluid applied air barrier at that jam. And the other photo is a tricky sill connection, which once again is just simply Prosoco products, which are just gooped in there to really just protect the building and create continuity in the air barrier.
We made it.
This is one of the better days on the projects. I have to admit, I lost sleep before we got this first blower door test. There's just no way of knowing as you're working through construction. But anyway, we hit our targets without having to use the aero barrier. And that was an amazing day based on all the hard work on a daily basis that we did to get the air barrier to work. Tom, you want to talk about the solar? I can chat a little bit. Essentially, we used these threaded rods that were epoxy doweled through the CMU. You can see there that part of the air barrier daily activities is to make sure that anybody that penetrates the air barrier, anybody that penetrates that outside wall, you have to be there with some type of goop to put it in there. So this is a little bit of the follow-up, and then you can see how the steel shafts were put on threaded rods to make sure that we weren't compressing the cement board. And that gave them the ability to mount the solar racks for the shading fan on the south. And then you can see the full solar array there on the roof.
Yeah, a little bit of a Sunmoto is the company that makes these PV racks. I call them Sunshield. But normally you're just going to like attach that to a wall, but we had, 6 inches of insulation that we wanted to run continuously there. So we worked with our engineer to come up with this threaded rod connection. So that's how that worked. I'm sure we're over 15 minutes, but that's it. They didn't cut us off. We made it.